Okay, we're going to look at some properties of triangles that you may not have seen before. First property is that the longest side of a triangle is always opposite the largest angle. So if you look at the first triangle here, which one is the longest side? What you can see here is 9 is the longest side, here the green side. And you can see that it's opposite the largest angle. All right, so 84 degrees is the largest angle. So longest side always opposite the largest angle. And have a look over here. Clearly, the blue side is longest. It's 13 units long. And look at the angle. It's opposite the largest angle in the triangle. So for any triangle, the longest side is always opposite the largest angle. And you can see that here. If I move my triangle around so that the angles change, you can see that no matter what I do, I can't change the fact that the longest side, here in this case 16, is opposite the biggest angle. Let's change that triangle around again. Here we go. Now the longest side is, this time it's 6. I'll make it 7 this time, yeah. It's 7, and the largest angle is here, 75 degrees. So longest side always opposite the largest angle. Now if you're wondering about how we could have got a 6 before, obviously that's a bit of a problem. But if we change the decimal places to 1, there we go. We've got more accurate measurements now, so you can see that the longest side in this case, which is 6.1 now, is opposite the biggest angle. Okay. All right, the other thing is the sum of the lengths of the two sides of a triangle must be greater than the length of the third side. So that means pick any two sides. So let's look at the red side, which is 7, and the blue side, which is 6. If you add 7 and 6 together, it's bigger than the third side, isn't it? Which is only 9. 7 and 6 is 13, which is bigger than 9. Let's pick another two sides. 6 and 9, if I add those two together, I get 15. That's obviously longer than the third side, which is 7. Okay, so pick any two sides of the triangle, add them together, and it's going to be longer than the length of the third side. Okay. All right. Now, what about concave and convex quadrilaterals? This is something else we have to know. So, what is a convex quadrilateral? Well, it's a quadrilateral where all the corners point out. And more importantly, the diagonals, which are the dotted lines, lie inside the quadrilateral. Okay, so that's the main features. So the corners point out and the diagonals lie on the inside. Over here, we've got a non-convex quadrilateral, which we also call a concave one. So let's make a note of that. So non-convex is also called concave. I think this is a better word because I think of this concave meaning caving in. So, and you can see here that the very non-convex quadrilateral, that the corners cave in, don't they? You can see they point in. So here you've got the corner which is pointing in. All right. So that's one property. The other property is one diagonal lies outside the shape. So if you look at the diagonals of this shape here, so if I just join the opposite corners, so here's one diagonal, I've joined the opposite corners there, and here's another diagonal, joining opposite corners. You can see that the second diagonal lies outside of the main shape. Okay, so if I draw the main shape there, let's just do this in a different color. So the main shape is there, and there, there to there, and then so the blue part is the main shape and the red part is the diagonal. So you can see that for a non-convex quadrilateral, one of the diagonals is outside of the shape. Okay. The other thing to note is one angle is more than 180 degrees. All right, so if you have a look here, let's change colors. All right, so this angle here, you can see there, that angle there is more than 180 degrees. That's a reflex angle. Whereas if you go back to your convex quadrilateral, you can see every angle inside the shape, every single angle is less than 180 degrees. Okay. All right, so there we go. So now we know how to tell the difference. Let's have a look at some questions. Now, in each quadrilateral, which is convex or non-convex? All right, now remember, non-convex is the same as the word concave, caving in, pointing in. So let's have a look. Which one is this? Is this one concave or convex? We can see all the corners are pointing out, so that's convex. Okay. Part B, you can see all the corners are pointing out, so that is convex. Now, what about part C? You can see that I've actually got corners pointing in. Okay, and also you can see that one of the angles inside the shape is a reflex angle. So that is actually non-convex or concave. Okay, you can say also concave. Right? Part D. Right, so for part D here, you can see here I've got one of the corners pointing in again. So it's pointing in, pointing in. I've got a reflex angle there as well. So this is concave or non-convex. All right. Now the other two shapes, you can see the corners are all pointing out. So they are convex. Okay. And that's all there is to it.